We're moving to the new chapter that's about the determinant of a matrix, and the definition is determinant of matrix is a number associated with the square matrix. The matrix is not the rectangular. This is only for square matrix like 2 by 2, 3 by 3, 4 by 4, number of rows equal to number of columns. We can denote it by this symbol or by this symbol. We'll discuss it further. So first of all, we take the definition of the matrix we want to evaluate. Matrix is 2 by 2. This one matrix A, 2 rows, 2 columns, A, B, C, D. We have already used this one for finding inverse. So just what we do, we multiply A and D and take here plus sign. And we multiply C and B, we take here minus sign. So the signs are very important. Just remember it because we are going to use it many times. When we want to find determinant of A, determinant of A is AD minus CB. So this will become a number. I will show you with the help of example, and we can just see it. I have an example here. My matrix A, I take matrix A is equal to 2, 5, 3, 7. So when I find determinant of A, my determinant of A is 2 multiplied by 7 minus 3 multiplied by 5, and that's equal to 14 minus 15 is equal to minus 1. When these are real numbers, then this is also a real number. When these are functions, then this become a function. So it can be just multiplication of 2 multiplied by 7 and 7 multiplied by, here we get these 2 and multiply 2 and 7, we get plus sign, and 3 and 5 we get here minus sign. So that's very important to note that when we having here, then we are having this direction for plus and minus. It's very simple when we're going to calculate the determinant of matrix, which is 2 by 2, and this is being used in a lot of use of this one, and we are going to discuss one we are using. So mainly when we want to find the evaluate the matrix which is 3 by 3, that's the real challenge, and we have to know that one, that how we are going to find this one. So I explain you this one. This is 3 by 3. We evaluate the matrix. Evaluate the matrix, which is here is evaluating determinant of matrix, determinant of a 3 by 3 matrix. So I take here matrix A. I define this one as the first row is A11, A12, A13. I'm having A21, 2 represents the second row, 2, 2, 2, 3. Then A31, 3 represents the third row, A32, A33. So this is my matrix which is 3 by 3. I want to find the determinant of this one. I can write here determinant of A. When I write determinant of A, then I start from the first row or first column. That's same. I start from the first row column. Write here A11, then write here determinant. What is left? What we do? We are having here A11, so we remove this row and remove this column. What is left, that we write as a determinant 2 by 2, and that one here is A22, A23, A32, A33. This A11 is plus. Now when we want to take this A21, we get here minus sign. I will explain you the further details of that one, that how and why we can get this one here. Now I remove this, and now I block my row which contains A21, that's my first row, and I block this column. And what is left, we write here. Here I take the sign minus sign, A12. What's left is A21, A23, A21, A23, then A31, A33. Then we're plus, same row we are following, A31, and for A31 now I am going to block this first row containing A31, that's my first row, and I block this one, and I block this column. So here now we can see when you block this row and column, I'm blocking this column. What's left? A21, A22, A31, A32. So I write here A21, A22, A31, A32. Now simply I open these all the three determinants and I can write the value. This here is A11 multiplied by A22, A33. Same rule we're going to apply. Here with plus sign, here minus sign, minus A32, A23, then minus here A12, and we get here A21, A33, minus A31, A23, then we have plus A13 into A21, A32 minus A31, A22. So this is the determinant of matrix real number, and we can see it here again. We're having here multiplying them with plus sign and then minus sign here A21, A33 plus sign, A31, A32, A32 with minus sign, and then here again A21, A32, A21, A3 plus sign, and this here is minus sign. So the value we get by this way, that is the value of our determinant. So I explain you this with the example. I take an example, we find the determinant of a matrix. Example is find determinant of matrix. So matrix A, I take here matrix B, and I'm having here 2, 4, 5, 3, 6, 8. And the last row we are having here 4, 5, 9. We have just defined that condition that this must be a matrix which is 3 by 3. Must be a square matrix. Solution of this one, I write determinant of 3. So I start from determinant of B from the first row. This is my first row that contains 2, 4, and 5. This is plus sign, this is minus sign, and this is plus sign. So I write here 2, and into the cofactor we call it. What's left? We block this 2 column. What is get 6, 8, and 5, 9. Then we have minus 4. Then we block the second column. We get 3, 8, 4, 9. 3, 8, 4, 9. Then we block the third column. We have 5. Multiply by, I use 5. Multiply by, I block this column, this one, with 3, 6, 4, 5. 3, 6, 4, 5. Now what I do, I'm going to write here the solution of this one. So this is equal to is 2 into, I multiply here 54 minus 40, then minus 4 into 27 minus 32, and then plus 5 into 15 minus 24. Same rule. I multiply here plus sign, I multiply these two with minus sign. I took the signs and we get here. When we simplify this one, we get here 2 into 14 minus 4 into minus 5 plus 5 into minus 9. Solve it. I get here 28 plus 20 minus 45. This gives me 48 minus 45 is equal to 3. So 3 is determinant of the matrix B. So this is a real number, as I said. We can have a number which is related to determinant is a number associated with the square matrix A. Here the number value of this one was equal to minus 1. Here we get the value is equal to 3. That's how we can calculate the determinant of matrix, which is 2 by 2. Simply the formula is the multiply here with plus sign, multiply here with minus sign. For 3 by 3 matrix, our setup is we get A11 with plus sign, A12 with minus sign, A13 with plus sign, and then related with the, we multiply by the determinant, block this column with A11, this row and this column, we get A22, A23, A32, A2. Then for A12, block this column, this row is blocked also. We block the column and row which contains this value A12. Then get A21, A23, A31, A33. Then A31 block this row and block this row. And this row is blocked and this column is blocked. What's left is A21, A22, A31, A32, and we just solve it by the way we are doing it, and we can just write the value. And I give you this example. As the example, we take the first column, first row, opening, this is 2, this is -4, this is 5, the signs are plus, minus, plus. We block this column, we get 6, 8, 4, 9. We block this column, we get 3, 8, 4, 9. We block this column, we get 3, 6, 4, 5. We are having these values. We call this one, this here, we call it as this one as, we call it minor. We say minor of A11 is this value, A12, A22, A23, A32, A33. This is a minor. The second one is we denote it by M11. Then we define cofactors. Cofactor C11 of A11 is cofactor of A11 is equal to -1 to power 1 plus 1, and then we are having here again the same A22, A23, A32, and then we're having A33. So this is cofactor, this is here the value. So this is two words I have introduced. One is the cofactor, the minor of A12, and then the next is cofactor of A12. What's the difference? Difference between the two is the sign. When you multiply by this sign, and if I take here the minor of, I say I want to find cofactor of Cij is equal to -1 to power I plus j into Mij. Now you can understand why I took here plus sign, why I took here minus sign, why I took here plus sign. With this one, here is this very important. We get here +2 plus sign, we get here minus sign, and then we get here plus sign. These are the signs of the cofactors. So we are having here, we multiply this one, we say determinant of B is equal to B11, B capital 11, then B11, and then cofactor we write here C11, then B12, I write from the my result related to this matrix A, that will be better. We want to find determinant of A. Determinant A is A11, C11 plus A12, C12 plus A13, C13. So what are the signs of A11? Sign with A11 is plus. A12 sign of C12 from here. We get I plus 1 plus 2 is 3. So get here this value minus. Then here is plus. So if I just write the cofactor, the whole of the matrix, just the signs of that one. So the cofactor sign will be plus A11, A12, A13, A21, A22, A23, A31, A32, A33. When I plus j is even, we get here plus value. When I plus j is odd, we get here minus value. So this is the idea for the signs. We can use this idea and we can just decide is a plus or minus. Similarly, I can open this one by the first column. This will be, if I open it from first column, I can write here my determinant of A. When opening from the first column will be determinant of A will be equal to A11, C11 plus A21, C21 plus A31, C31. So very interestingly, the result will be the same. You open from any row, if you are taking the first row or first column, or we say from any row, from any column, we calculate our determinant, the value is same. So what are you doing? We are having A11 multiplied with its cofactor. The cofactor is having sign -1 to power I plus j and Mij. Mij is what? Minor. Minor is the determinant of A11. We remove this one and this one. Whether the determinant of A13 is this one. Then here A13 multiplied by C13, and C13 the value is, no, actually we have done this one by 3 by 3 matrix. We can extend it by 4 by 4.